All right, so we just finished some calculations using Excel, right? And well, computers save our lives in many different ways. Because in the old days, and I'm talking like pre-computer era, um, there there were statisticians or people who were hired just to do the calculations that Excel did in about 30 seconds. Okay, not even, well, I should say 0.30 seconds. Um, so they would just have to do all these sorts of calculations for a particular normal curve. So to save themselves time, what they want to do is try and standardize this process, or kind of say, can we do this calculation once, and then whatever we're working with, can we just kind of translate it into that one thing? And luckily, they found a way to do that. And so they said, okay, if we have some random variable that is normally distributed, it has its own mean and standard deviation, what we can do is make it into this new random variable just by subtracting the mean and dividing the whole thing by its standard deviation. And when you did that, what happened was the mean and standard deviation shifted to be 0 and 1 respectively. So now we're in this realm where we have a random variable that follows a normal distribution with a mean of 0 and standard deviation 1. And that, my friends, was called the standard normal distribution. I shouldn't say was, it's is called the standard normal distribution. And so what statisticians did is they did a bunch of calculations for this one distribution and said, well, if you need a probability or an observed value, get it to the standard normal distribution and work with it there, and then you have to kind of do a little bit of math to translate it back. And so so we're all on the same page, when we talk about the standard normal distribution, it is a normal distribution, but again, it has mean 0 and standard deviation 1. So we can measure out our, if we think about the empirical rule, we'd have 1, 2, 3, and then -1, -2, -3. And again, effectively, all the data would be within, 3 standard deviations of the mean. Okay, so that's kind of why, kind of how things were approached in a historic sense. Okay, now though, with technology, we don't need to always we don't always need to go back to the standard normal distribution. Okay, but there are pieces of it that are still, or this pieces of it that are still really helpful. Okay, and in the process of converting to the standard normal distribution, right? This standardization process where we subtract the mean and divide by the standard deviation, that's called standardization. But when we do it for a specific value, so again, a little x, not a big X, transforming little x to a little z is done in the same way, but what we get, this little z that we get, that's called a z-score or a standard score. I think z-score is just quicker to say, so I say z-score. Okay, and what this is useful for, okay, so we would get a value. So let's pretend we have a normal distribution that follows a mean of, or a normal distribution with mean 6 and standard deviation 2. Okay. Um, so, and let's pretend we have a little observation that is, 9. Okay. So then we can find its standard score, or its z-score, by just doing, 9 minus 6 over 3, or over 2 rather, and we get 1.5, 3/2. Okay, fine. But what that tells us is that, okay, our observation is about here, and so, it's about it's 1.5 standard deviations from the mean, which that in itself is really helpful. And then we can approximate, okay, we know below 1 is 84% of the data using the empirical rule, so we're in the range of 90%, the 90th percentile range. Okay, so that allows for kind of some back of the envelope calculations or some rough thinking to accompany this, and it kind of tells us, at least in a vague sense, how peculiar our observation is. So in an example of this is actually pops up in MRI scans. So via certain activities, you can do, or actually no, not MRI, fMRIs, functional MRIs. And during those scans, when you're, doing neurological things, I don't know exactly what it would score, what context this would pop up in, but it actually gives you a reading out on a z-score scale. And so we can see, okay, at least down here, right, this part of the brain, okay, I don't know what part it is, but that part of the brain, there's some really odd behaviors because your z-score is up at 5. So you are like 5 standard deviations from the mean. So something really odd is going on here. And that gives you more information to continue your investigation. Okay, so z-scores are still used, even though standard normal distribution isn't used itself specifically. So z-scores can give you an indication about how peculiar things are, and so you'll get some practice with that in the activities.